In this lesson, we will be learning about DC motors. Previously, we've learned about DC generator. And in DC generator, we know that it converts mechanical energy into electrical energy. And we encountered the formula generated EMF is equal to P, number of volts, times number of flux, the speed, number of conductors, divided by 60 times A. And we know that E is the generated EMF. And in DC motors, we will be using the same formula. However, since this is a motor, and when the motor starts rotating because of electricity, there will be a back EMF generated. So we will just put B and we will call it back EMF. And I already listed down all the formulas that we're going to use to solve problems in DC motors. To solve for the speed of the DC motors, we will use back EMF formula, and that will become En is equal to the back EMF times 60 times A divided by number of poles, number of flux, and number of conductors. And we will also be using another formula that is N is equal to K times the back EMF divided by flux, where K is a proportionality constant. For the torque developed in the armature, since motors are rotational, then there will always be torque developed in the armature. That is T is equal to 9.65 times power developed divided by N, wherein power developed will be equal to the back EMF times the current in the armature. And also, we have T is equal to number of volts times number of conductors, flux, and current in the armature divided by 6.283 times A. And we will also have T, or torque, is equal to the proportionality constant times the current in the armature and the flux. And in mechanical power output, we will be using two formulas. Actually, they are the same, but it changes with its denominator. The first one is we use 33,000, and the second one we will be using 44,760. Now, when are we going to use 33,000 and when are we going to use 44,760? So if the unit of the torque is in pound-foot, we will use 33,000. And if the unit of the torque is in Newton meter, we will use 44,760.